So let's talk about building database code. This is the first part of the CI process. And what we want to do here is start from scratch with no existing database and ensure that all of our code can be executed on a valid database server without any error, without any problems. Our process is to feed the code files to the server in the correct order, pulling them from version control. Kind of function as a pre-compiler here, since the database server can really only evaluate each object code separately. So our first part of our compile process is that we get all of the code together, we ensure that it compiles, and then we report errors if it doesn't. If not, we can move forward with the rest of the process. So let's look at how this works depending on our development model on each case. In the first part of this, let's talk about state-based development. A build in the state-based development world talks about creating a scratch database and executing that code against the server. In this case, what I need to do is execute each object in the proper order. So tables typically have to come before indexes. Views probably come before anything else. Stored procedures, functions may or may not come next. But we have to work out the ordering here. And this is where some sort of comparison technology becomes important, because it will build a dependency tree and ensure that we can actually build our database in the correct order with all the correct files. Now, if there are migration scripts or data manipulation scripts or some sort of other items that have to be included, we have to add them to this process in some place. This doesn't ensure upgrade scripts will work, but it does provide a quick fail-fast test of our code and make sure that it's syntactically correct and all the references work out correctly. Now let's look at migration-based development. Now in this case, the ordering is provided by the scripts, right? That's an easy part. We execute each migration script in order. All the scripts have to be run from the first to the last, because in this case, we're starting with a blank database, so we need to run the first script, the second, the third, all the way to the end. And again, this mimics the actual actions that we took during development, all the scripts we ran in the correct order. And it ensures that our scripts do correctly build a complete database to the point in time where we stop development, or the point in time that we committed to version control. And again, we execute all these scripts as part of a build, not an upgrade. That part of the process gets tested later. Now, there are certain edge cases where we have valid code that will work for an upgrade, but it may not compile correctly in a build process. These are typically edge or corner cases because they're unlikely, but they're certainly possible. For example, if I decide to alter a table and add a not null column, I need a script to handle the data manipulation. But suppose there are views that depend on this table, and I also include code to refresh those views. I want to make sure that any select star issues are caught. It's valid code. When I upgrade a database, that will work perfectly. But when the CI process builds a database, it has to decide where to execute this script. Now, if the script runs at the end of the table creation process, but before the view process, that returns an error because the view doesn't exist. I can't refresh it, I can't alter it. If the script executes at the end of the build, then other views or tables might have execution errors because we didn't alter that table at the right time. Handling these edge cases in a build is problematic. There's many of them and there's no easy solution. One way to do it is to revisit your code and refactor it and try to move your changes that cause errors to separate scripts that can execute at different times. So for example, rather than refreshing a view when I alter a table, make sure I always refresh my views at the end. Now, if that doesn't work, you may have to find some other workaround to handle your particular edge case. But again, DevOps is about experimentation, understanding what works in your environment, and making those changes. Now, once you have a successful build, chances are your workarounds may not be needed in the future, and they're not a part of your deployment code. They may not even be part of your build code in the future, but you'll have to test and determine that for yourself.